Alright, so in this video we're going to talk about solving inequalities, and I'm going to talk about two different sections at the same time in this video. We're going to talk about solving inequalities that involve addition and solving inequalities that involve subtraction. So addition and subtraction are the same thing, they're the opposites of each other. We're also going to talk about solving inequalities that involve multiplying and dividing. To begin, essentially, in general, when you're solving inequalities, except for one special rule we're going to talk about in a little bit, in general, when you solve inequalities, it's exactly the same way as solving equations. So I wrote solve the same way as equations at the top, meaning everything that we're doing, the how to get the variable by itself, that's all going to work the same. So all the things you remember about solving equations back in chapter 3, about solving for a variable, getting it by itself, meaning moving everything away from the variable by doing the order of operations in reverse, moving those things by doing the opposite operations, all that still applies. That's everything we're going to use to get our variable by itself. The only difference is we're not going to have an equal sign. But if you treat it almost like it is, except for that one special rule I'm going to talk about later, it's going to all be exactly the same. So let's take a look at this first example. This first example says x plus 4 is greater than 9. So if you have x plus 4 is greater than 9, what you're going to do is you're going to say, okay, I got to get x by itself. So how can I get rid of plus 4? And to get rid of plus 4, we all learned back then is you do the opposite. You subtract 4. So if you subtract 4 from both sides, they cancel on the left. And when you do that, on the left, you're left with just x. On the right, you have 9 minus 4. Well, that's 5. You have the greater than symbol. So greater than. So that means the answer to your question is x is greater than 5. Now, I know that seems silly in terms of it's not an equal sign. We're used to seeing an equal sign there. So if this had been an equation means equal, we would say x plus 4 equals 9, and then we would say x equals 5. But because this is an inequality, this is saying we want to know what values of x will make the left side, what values of x will make our left side be greater than 9. So we want to see no matter what possible values, because there's more than one, can make the left side equal more than 9. So and the answer we got was everything bigger than 5, meaning not including 5, because it doesn't say greater than or equal to. Remember, this is greater than or equal to. When it has that underline underneath, that means or equal to. It just says greater than 5, and let's test it. If we plugged in a 5 and for x in the front, we'd have 5 plus 4. Well, that is 9. Is 9 greater than 9? No, it's not. 9 is equal to 9, not greater than 9. So we have to choose things bigger than 5, such as 6. 6 plus 4, well, that's 10. 10 is greater than 9, so 6 is a solution. So anything that's bigger than 5, that's an answer to this question. It is a solution that will make it true. So there's many answers. So rather than trying to list all of those possible solutions, we simply, because it goes to infinity, we would just simply say everything bigger than 5. So x is greater than 5. The solutions to this inequality is any number greater than 5. And so that starts off with 5.001. Also, you can go infinitely close with how many zeros? 5.00001. Anything that's slightly bigger than 5 or really bigger than 5 is a solution to that question. We'll make it true. So now let's go on to the next question right below it. It says negative 12 is greater than or equal to n minus 9. So negative 12 greater than or equal to n minus 9. Same priority here. We got to get n by itself. So we have to get rid of the minus 9. So to get rid of the minus 9, we add 9. So add 9 to both sides. Cancel on the right side. And when you do that, you're going to be left with just the n on the right side. The greater than or equal to is still there. Now, negative 12 plus 9. You got to use your negative skills. Negative 12 plus 9, that means you're starting in the negatives. You're adding, so you're going to the right, which means you're heading towards 0. You're not going to make it to 0. You're still going to be in the negatives. So that you're going to be left at negative 3. You could have done that also as 9 minus 12. That will also give you your negative 3. So we found out that negative 3 is greater than or equal to n. Now, that is true. That is your answer. However, when we start to talk about graphing like we will in the next example, it's going to confuse us a little bit if we don't always put the variable on the left. So let's get in the habit of our final answers. It's not technically required, but it does make your life easier when graphing it. It doesn't make you have to think of it backwards and confuse you. So if you want to avoid that headache, just always get in the habit of putting the variable on the left, moving into the left side. Meaning, when you're writing this inequality, actually physically having the n on the left side instead of the right side. But if you do that, you have to also watch the inequality. You'll notice our gator, if those of you like calling the inequality sign gators, there's on my teeth in my gator's mouth. He wants to be eating the negative 3. So when we flip all of it, it must still be wanting to eat the negative 3. So when you flip it, it's no longer greater than or equal to. It's now less than or equal to. So it tells us n is less than or equal to -3. They mean the same thing. So both of these are your answers, but the one on the right is the one that's easier to work with, and the one on the right is the one that's easier to graph once we start talking about graphing in just a moment. Now, intuitively, if you want to think of it this way, if -3 is greater than n, that means -3 is bigger than n. If -3 is bigger than n, that means n is smaller than -3. So that's essentially what we wrote over here, n being less than or equal to -3. We essentially said what is implied, or what's the opposite that is also true of the original solution. So putting the variable on the left can make your life easier. So now let's take a look at another example. Now in this example at the top, there's nothing different other than it looks like it has some fractions that make it look harder, and it's also saying graph your answer. So we'll talk about graphing in just a moment. But for now, let's look at the question we have to solve. It says a plus 1/3. A plus 1/3 is less than 1. That's what it tells us. So just like any other question, in order to solve this, we had to get rid of plus 1/3. Well, we do that by doing the opposite. The opposite of plus 1/3 is subtract 1/3. So we minus 1/3 on both sides. They cancel on the left side, and we're left with just a. So we have a is less than. Now 1 minus 1/3, or 1 whole minus 1/3. You can show your work by doing 1 whole. 1 can be 3/3. And then you can minus your 1/3, and you get the 2/3. So that's one way to get 2/3. Or some of you might just realize a whole minus a third. So if it's a third, that means it's 3 of them. If you take away 1 of them, you still have 2 of them. So you still have 2/3. However you want to do it, that's fine. But regardless, we end up with a is less than 2/3. The fact that it's a fraction doesn't matter, so that doesn't affect anything. So what we're going to do is we're simply just going to now interpret that. So let's graph that answer. So if a is less than 2/3, even if it was a less than 2, a is less than 2, or a is less than 3, it doesn't matter. Whatever it's less than, you go to that item. So take a look at this. If it's less than 2/3, you go to 2/3 and you're going to put a circle. I'll talk about why it's a circle in a minute. You're going to put a circle at 2/3. And remember, 2/3 is between 0 and 1, but most of the way to 2. In fact, 2/3 of the way to, I said most of the way to 2, excuse me, most of the way to the 1. In fact, 2/3 of the way to 1. So it's past halfway is what I'm saying. Okay, now the question says less than. So you ask yourself, which way is less than on the number line? 2/3 is the magic number, where that's that fence where all of a sudden it's either a solution or not a solution. It says everything less than that. Well, you guys remember everything less than that. Things that are less are always to the left. So everything to the left of 2/3, all of this stuff, all of this is the solution to your question. Everything that's smaller than it, everything that is to the left, everything is less than. So to graph your solution, you're going to draw a circle and you're going to shade in an arrow that's going to the left. Now, you can do it over the number line, above it, or you can do it on top of it. As long as you're kind of trying to be neat and organized where you see your numbers. My preference is generally do it over it so that you can still see the numbers and everything, or if you need to erase it in class, you don't have to erase your number line. So essentially, I want you to know that because it's less than, it's going to the left. Now, when you have your variable on the left side of your answer like this, it makes your life easier because it's almost as if looking at the inequality is almost like an arrow. That less than sign is actually looks like it's pointing to the left, and so it kind of tells you shade to the left. It's everything to the left. However, if you would have this answer in the opposite order, that means the same thing. 2/3 is greater than a. That one's not as obvious how to graph. You would think, oh, greater than makes one a shade to the right, but that's not true. It's all based on a's perspective, because if 2/3 is bigger than a, that means a is smaller than 2/3, which means you should be shading to the left of 2/3. So the second way of writing it is kind of confusing. So you're not going to see me graphing it from that form. You're going to see me always putting the variable on the left side before I graph. Now, I want to make one more note, something that is important to note. Whenever you're graphing, whether this is an open circle or a closed circle depends on this. If your answer does not include, if your solution set does not include your number, like here, 2/3, it does not include 2/3. If it did include 2/3, it would say less than or equal to 2/3. Now, it doesn't say that. It doesn't say less than or equal to. It says just less than, meaning it does not include 2/3. So if it does not include 2/3, or if it does not include your number, meaning if you have less than or greater than, you're going to have an open circle. However, if it does include your number, so if it says less than or equal to, or greater than or equal to, that is going to be a filled in circle. where it actually, when you go to graph it, you're going to say it includes this number, so I'm going to color it in. So if it's less than or greater than, not including that number, it does not include or equal to, it's an open circle. But if it does include the or equal to, it's going to be a closed circle because you're showing it includes that number. So keep that in mind when you go to actually put your circles or dots on your number line, whether it's going to be an open circle or a closed circle. That's going to be what determines it. So now I'm going to skip over numbers 1 through 4 at the bottom. I'm going to go straight to 5 and 6. That way we can do 2 more examples and make sure that we're also demonstrating how to graph it properly. Then we're going to move on to the next section. So now, actually we might do maybe 1 or 2 word problems with this. Okay, take a look at number 5 at the bottom. Number 5 at the bottom says, the instructions say solve each inequality, graph the solution set on a number line. It says s plus 8 is less than 9. S plus 8 is less than 9. So that means we have to get rid of plus 8. Well, to get rid of plus 8, we're going to subtract 8 from both sides. So first let me start by writing the question, because I don't have room to show my work down there. Let's be a little more neat and organized about this. Alright, so if we have s plus 8, so this is for number 5 at the bottom. S plus 8 is less than 9. Okay, like we were saying a second ago, to get rid of plus 8, we subtract 8. So subtract 8 from both sides. They cancel on the left side. And if you do that, you're left with s less than symbol. So s is less than. 9 minus 8, that's 1. So that tells us the answer is s is less than 1, meaning the answer is everything less than 1. It does not say or equal to, so that means it's not including 1. So when you go to graph this, it's going to be an open circle over the 1. It is not going to be a colored in circle. It says it's everything less than 1, so s is everything to the left of 1, meaning less than 1, so it's smaller. So that's a fast way for you to graph your answer to number 5 of s plus 8 is less than 9. It's everything less than 1, so that's your graph for it. If you think you got this, hit pause, try number 6, and see if you can do number 6. In number 6, we have negative 3 less than or equal to d minus 2. Okay, to d minus 2, to get rid of minus 2, we're going to add 2. Do the opposite. Cancel on the right side. So we're left with just d over there. Now on the left side, we have negative 3 plus 2. Negative 3 plus 2, that's heading back towards 0, so that's going to be negative 1. So you have negative 1 is less than or equal to d. Now you'll notice in this example, I have the variable on the right side. I like to see it on the left side. It makes it easier for you to graph it. So I'm going to put the d on the left side, put the negative 1 on the right side. The alligator is previously eating the d, so the alligator must still be eating the d. So its d is greater than or equal to negative 1. So now it's easier to graph it. It's greater than or equal to negative 1, meaning this time it includes the number. It includes negative 1. So that means this one is going to be a colored in closed circle. It includes negative 1. Now since it says greater than negative 1, it's everything to the right of negative 1. So you're going to shade your arrow going to the right like that. So those are 2 more examples of solving one-step addition and subtraction inequalities. Okay, so each of these examples at the top, 5 and 6, they don't tell us we had to graph it, but I'm going to probably, if I have room, I'm going to graph the results anyways to help make sure we're practicing graphing. At least one of them. Alright, so number 5, the one on the left, says Petra must write a report with more than 1,000 words for her history class. So far, she has written 684 words. Write and solve an inequality to find how many more words Petra needs to write for her report. So it says more than 1,000 words, which means because it says more than 1,000 words, that means it would be unacceptable to write 999 words. It would be unacceptable to write 1,000 words. It says more than 1,000. So that means it cannot be or equal to. It's not going to include 1,000 words. It has to be more than that. So in this question, regardless of what we're doing, we're going to say it's going to be greater than 1,000. That's how the end of this question has to end. We have to say that it is greater than 1,000. So now whatever's going on in it. So now it says, so far she has written 684 words. Write and solve an inequality to find how many more words Petra needs to write for her report. So if she's already written 684, essentially she's written 684 plus how many she still needs to write. That's got to equal her minimum of 1,001 words, essentially. That's got to meet that minimum. So she's going to add those together. How much she's written plus how much she still needs to write. Those things added together are going to equal how much she has to write. So what we're going to say is 684 words. Now in this question, most of you are probably already realizing you're going to solve this by subtracting. That was intuitive, but I just want to talk about how to set it up. So 684 words plus some amount she still has to finish. We don't know what it is. We're calling it X. is greater than 1,000 words. That's the inequality to model the situation. And that's essentially what they were asking you to do when they said write it to model it. Now, yes, a lot of you would have already intuitively known subtract from both sides to find out how many words are left. I'm aware of that. I want to make sure we were clear on how to set it up, though. So minus 684 on both sides to get rid of positive 684 or plus 684. Cancels on the left. And if we do that, I'm going to jump down here where I have space in number 7, where we're left with x is greater than. Now you just got to figure out what is 1,000 minus 684. Well, that's going to give us 316. So x is greater than 316. So that tells us as long as she writes more than 316 words, she's going to finish. She's going to meet that requirement and write more than 1,000 words for her paper. That's what that tells us. So because I have room for this one, I'll go ahead and graph this one, but otherwise I don't know if I would graph these because I wouldn't necessarily have room. But let's take a quick look at it. If you don't have a number line and it tells you you need to graph it, make your own. So let's make a number line. Slap 316 somewhere in the middle. That's fine with me. That is an ugly 316. I'm on the edge of the screen. So that would make this next number 317. This next number 318. Sorry, so messy. I'm on the edge of the screen. It's not reading it very well. Alright, anyways, so if it's greater than 316, you're going to 316. It does not include 316. It has to be more than that. So it's got to be an open circle over 316. It says greater than, so you're going to shade this in going to the right. So hopefully that was a last chance reminder. So now take a moment, try number 6, hit pause, give it a shot yourself, and then press play and see how you did. Alright, this question uses the words at least 72 inches tall. It says Leslie hopes to be at least 72 inches tall. Now, that word, at least 72 inches, that's the key word here. At least means something. If you're going to be at least something, that means you do not want to be less than it. At least it means you're okay with being that number, but you're also okay with being more than that number. So when we say at least 72, we're saying greater than or equal to 72. Her height wants to be greater than or equal to 72. I'm going to put a little dash inside my 7. So you're going to be greater than or equal to 72. It's unacceptable to be less than, but everything else is okay because you have to be at least 72. Right now he is 56 inches tall. Write and solve an inequality to find how much more Leslie would like to grow. So just like the previous example where it was how much we wrote and how much more we have to write, if he's already 56 inches, we got to say 56 inches he's already grown plus how many he would like to grow. That'll equal how much his goal is. And for him it's greater than or equal to 72. So 56 plus x is what we're going to do in this example. Because how much he is plus how much he wants to grow, we don't know how much that is, that's what we're solving for, has got to equal his goal of at least 72 inches. So you're going to solve this. Got to get rid of plus 56 or positive 56. The opposite is minus 56. So subtract 56 from both sides. So on the left side, we're left with just x. So x is greater than or equal to. Now on the right side, we have 72 minus 56. 72 minus 56, that's going to be 66, 16, I believe. Let me not get too cocky. I'm multitasking. Minus 56. Yep, 16. Okay. All right, so x is greater than or equal to 16. So that is your answer. It includes 16. So if you were to graph this one, I'm not going to take the time to draw the number line, but you would have a filled-in solid circle over 16, and then you would go to the right to graph it. And that's how you would graph your answer. Other than that, we've solved it. We've now found how much would he like to grow. He would like to grow at least 16 more inches. Now we're going to take a look at some examples for about multiplying and dividing, but I think before we do, I'm going to briefly review to make sure we're on the same page about something. Certain words mean certain things. When you see at least, that means greater than or equal to. If you see something that says no more than, as in not more than, if it says that, that means everything is okay as long as it's not more than. So it's like the opposite of at least. So if you heard something say no more than, like let's say no more than 5 feet tall, that means it can be 5 feet tall, but it can't be more than it. So it can be less than it. So if you heard someone say not more than or no more than, that means less than or equal to is what that means. So I just want to make sure we're using our words. And in these sentences, they'll use words like that to give away what they're talking about. Okay, so in this section, we're going to talk about how to solve inequalities that have one step, or at some point we'll talk about 2 steps, multiplication or division. So in these questions, it's exactly the same. You're going to do exactly what we did back in Chapter 3, solving equations. in order to move something to the other side, you got to do the opposite to move it. Except now you just need to remember that the opposite of multiplying and dividing is multiplying and dividing. The opposite of multiplying is dividing. The opposite of dividing is multiplying. They're the inverses. They undo each other. So we're going to follow that. All that is exactly the same as the equation. It's going to be exactly the same as the rest of this video, except there's going to be one special rule we're going to talk about. I'm going to show you that special rule in a minute, but first we're going to go ahead and solve a question. Now, let me go to the bottom. Let me move these to some questions we can do that don't already have the answer. Alright, so take a look at exercise 1 on the left. We have 3a is greater than 12. That's what we're going to solve. So if we have 3 times a is greater than 12, we have to get rid of times 3, or a coefficient 3. The way you get rid of all coefficients we learned back in the day, or to get rid of times 3, is you divide by 3. So divide both sides by 3. And if we do that, we're going to be left with just a. So we have a is greater than 12 divided by 3, well that's 4. So you have a is greater than 4. That's the answer to our question. So now if it's time to graph that, we're going to go to 4. It does not include 4, so it's an open circle. It says greater than, so it's everything to the right of 4. So shade or graph and draw an arrow going to the right. That's what you do for number 1. For any time that works. Now take note. In number 1, we were moving a positive number to the other side. We were moving a positive number. Now in question number 2, we're going to be moving a negative number to the other side. We have to get rid of that divided by negative 2. R over negative 2, that means R divided by negative 2. Remember, fractions are division. So we're going to be moving a negative number, and this is where it activates a special rule. The special rule tells us anytime, I don't really need to write the whole thing, anytime you multiply or divide by a negative, both sides by a negative, it will flip your inequality. That's what that says. Now, there's a couple ways to explain why, but essentially what's happening is if you didn't flip your inequality, your answer that you would get would be false. It would be the opposite. It would no longer be true based on the original inequality. But if you simply flipped it, that would now make whatever you got as your answer. If you flipped your inequality when the special rule happens, it would make your answer true. It would make it always true for the original inequality. So now let's actually see it in action in number 2. So if we have, let me actually erase some of that real fast. Alright, so essentially, like I was saying, is if you had 6 is greater than or equal to r divided by negative 2, we're going to just get rid of divided by negative 2 by doing the opposite. The opposite of divided by negative 2 is times negative 2. So if you were to multiply both sides by negative 2, that's how you could get rid of it on the right side. So those would cancel on the right side, and we'd be left with, on the right side, just r. Now, on the left side, negative 2 times 6, well, that's a positive 6 times negative 2. Positive times negative, that's a negative, so that's negative 12. But now here's where it gets tricky, like we said. That greater than sign, that greater than or equal to, this is a special rule. We just multiply both sides by negative. We have to flip that. It's no longer going to be greater than. It's now going to become less than. So it's the answer to this question is negative 12 is less than or equal to r. It flipped. This is the only way it would be true. Now, some of you might be thinking, well, hey, unfortunately, we now have to flip everything again because we like to see the variable on the left so we can graph. But I want you to know what we're about to do has nothing to do with this step. Essentially, you've now done your job. You've done this special rule. You flipped the inequality. The inequality went from being greater than over here to being less than over here. But now, to make our life easy, make our brains work better when graphing this, we're going to go ahead and now flip everything so that we can graph it appropriately. So we're going to put r on the left, we're going to put negative 12 on the right. In our answer, the alligator is eating the r, so in our answer version over here, the alligator still needs to be eating the r. So we have r is greater than or equal to negative 12. So that's your final answer that's in the format that you can graph easily without hurting your brain. So it includes negative 12 because it says we're equal to. So go to the negative 12, and that's going to be a closed circle because it says or equal to. Now it says greater than. Greater than means go to the right. So this is how you graph your answer for number 2. So what we found is we have got our variable by itself, and we realized the special rule, what happens when you multiply or divide both sides by a negative. We'll do maybe one more example of the special rule, and then we're going to do some examples of two-step inequalities. Now, take a look at number 3 on the top left. It says negative 12 is less than or equal to negative 3g. Now, in this problem, you notice you're going to be moving negative 3 to the other side. it currently says times negative 3g, negative 3, it says times negative 3. You're going to get rid of that by dividing by negative 3. But you'll notice, well, hey, I'm now dividing by negative. So that's going to activate that special rule we talked about, that exception to where the only time it's not the same as regular old equations. This is because it only applies to this. Because if you go to flip an equation, an equal sign flipped is still an equal sign. Alright, anyways, so now let's go ahead and solve this. On the left side, we have negative 12 divided by negative 3, and negative divided by negative, that's a positive. 12 divided by 3, that's 4. Now on the right side, we have negative 3g divided by negative 3, the negative 3's cancel out, we have just g. Now, we have to activate the special rule. The special rule tells us that less than or equal to becomes greater than or equal to. So this is our answer. 4 is greater than or equal to g. Unfortunately, this problem happened again. I'm not doing these on purpose. It ended up to where our variable was on the right. So we're still going to have to do that final thing to make our life easy in order to graph this. So let's put g on the left. Let's put 4 on the right. Let's make sure the alligator is still eating the 4 even after all of this. So g is less than or equal to 4. That's going to be your answer that's going to help you answer this question. Now, less than or equal to 4 means it includes 4, so it's going to be a closed circle. It says less than, and so that's to the left. So you go to graph this, shade an arrow that's going to the left. That's how you graph your answers to questions like number 3. So that was another example of the special rule taking place. Now, a quick note, number 5 is not the same thing because in number 5 you're getting rid of divided by positive 2. So when you multiply both sides by 2 in number 5, you're actually, just because there's a negative over there doesn't mean anything. So you're going to end up with a is greater than, negative 4 times 2 is 8, negative 8. So a is greater than negative 8. That's your answer number 5. There's no flipping just because there's a negative somewhere in the question. But because we moved the positive, the special rule does not apply. So now we're going to do some examples of two-step inequalities where there's going to be more than one thing. But just like before, it's exactly the same thing as regular old equations unless at some point you find yourself multiplying or dividing both sides by a negative. Okay, we're going to do the two problems on the top left. We're not going to do the one at the bottom. So now, and for the two problems on the top left, our job is we're going to solve them. But we have to do what we learned about doing solving two-step equations. Meaning we're going to have to do the order of operations in reverse, which essentially, visually and physically, it's like starting by moving away what's furthest away from M and slowly working your way closest and getting your way closer to M. So the first thing we have to move in the first problem is the plus 6. We do that by subtracting 6 from both sides. They cancel on the left. And so on the left, we are left with m over 2, m divided by 2, and less than 10 minus 6, well, that's 4. So we have m divided by 2, or m over 2, is less than 4. So now we've done the first step. Now, just like any equation, keep going. We now have to get rid of divided by 2. Well, we said earlier the opposite of divided by 2 is times by 2. So multiply both sides by 2. They cancel on the left. And if you do that, you're left with m is less than 4 times 2, well, that's 8. So that tells us m is less than 8. That's the answer to this question. Anything less than 8 is a solution. And if you're not sure, let's test it. Let's plug in 6. If we plugged in 6 right here for m, if we put a 6 right there, that'd be 6 divided by 2. Well, that's 3. Now, then we would have 3 plus the 6 that's right next to it. So 3 plus 6 is 9. So we would end up with 9 is less than 10. Is that a true statement? Yes, 9 is less than 10. Checks out. So that means 6 is a solution for m. So that's an example we tested something being less than 8. Now I purposely chose 6 so we would avoid any confusion with decimals. If I'd put a 7 there, we would have 3.5 plus 6, which would be 9.5, which would still be less than 10. I was just trying to reduce the distractions. So now let's take a look at the second one. We're order of operations backwards. You got to get rid of adding before you get rid of multiplying. So you got to get rid of the plus 7. So the opposite of plus 7 is minus 7. Minus 7 on both sides. Cancel on the left. And if you do that, you're left with negative 6d is less than or equal to 1 minus 7. Well, that's negative 6. Now, notice, just because we got a negative answer on the right, it does not mean we flip the inequality sign. Just because you saw me subtract 7 on both sides, it looks like it's negative, does not mean we flip the inequality sign. Remember, I said equality, I meant inequality. The only time you flip an inequality sign is when you multiply or divide both sides by a negative. So you'll notice at this step, we're about to get rid of times negative 6 by dividing by negative 6. So yes, we're about to divide both sides by a negative number. That's about to happen in this question. So dividing by negative 6, I cancel on the left. And if we do that, we're going to be left with just the d all by himself. Now, negative 6 divided by negative 6, that's something divided by itself. Well, negative divided by negative, or something divided by itself, that's 1. So d, something 1. We just divided both sides by a negative, so we have to flip our inequality at this step. It's no longer less than, it's now greater than. Or it was or equal to, so it's greater than or equal to. So the answer to our question, to this example on the bottom left, is d is greater than or equal to 1. That means anything greater than 1, including 1, will make it true. So if you test it, let's plug in 1. If you put a 1 right here, that would be negative 6 times 1, which would be negative 6. Negative 6 plus 7, well, that's positive 1. So we would have positive 1 is less than or equal to positive 1. Well, hey, it says or equal to. Well, 1 is equal to 1, so that would be true. Now, just make sure we're not crazy. Make sure we're on the right side of 1. If d is greater than 1, like let's say 2, let's put a 2 there instead of a 1. If we put a 2 there, it's negative 6 times 2, which is negative 12. Negative 12 plus 7, that's going to give us negative 5. So then we would have negative 5 is less than or equal to 1. Well, hey, negative 5 is less than or equal to 1 because negative 5 is less than 1. So that would be true. So we're on the correct side of 1 is what I'm trying to tell you. In case you thought it should be d is less than or equal to 1. Because if you had tried 0 or negative 1 or negative 2, you would get something false that wouldn't work. And that would tell you that you chose the wrong solution set. You're on the wrong side of 1. But 1 is that magic number. It is that fence number where it changes. So these are two-step equations where, I said equations, two-step inequalities that solve just like two-step equations, except when you go to the multiply, divide both sides by negative, your inequality symbol flips. Now, I want to take a moment to show you guys a slightly harder one. Hopefully it's a review of old skills. Take a look at number 17 over here on the side. In this question, we have a variable on both sides. So you're going to need to think back what we did at the end of Chapter 3 when we had variables on both sides. And we talked about, we had a video back then that we talked about, I jokingly called it the mutant chicken method. We don't like to chase down two variables at the same time. So let's combine our variables all on one side right away. So we're not chasing down two unknowns, so we can only have one unknown. So let's go off that same premise. It is strategically the smart idea for you to always start by combining your variables if possible, moving them to the same side once you simplify everything. I always recommend moving the smaller variable towards the bigger variable, and if you do this, you will avoid negatives. And in this case, if you avoid negatives, you're going to avoid that special rule we talked about where when you divide by that negative coefficient, you'll end up having to flip the inequality sign. So save yourself effort by remembering those strategic things we chose way back when. So if we want to start by combining our variables, we see we have 1x on the right side and we have 3x on the left side. So we're going to start by moving 1x to the other side. It's positive 1x, so the opposite of that is minus or negative or minus 1x. So we're going to subtract 1x or just subtract x from both sides. Call it whatever you want. So they cancel on the right side, and if they do that, we're going to be left with, on the left side, 3x minus 1x, well that's 2x. So we'll be left with 2x plus 2 is less than. Now, that minus 6 becomes negative 6. Remember, in equations, plus, minus, positive, negative, it's wherever you need to be kind of at that moment. But if you really want to prove it, it's because there's technically a 0 right here. Because 1x minus 1x is 0, so we take off 0 minus 6. 0 minus 6 is negative 6. Alright, so that was a review on that. Alright, so now you'll take a look. We now have a two-step equation now that we've combined our variables. We now have just to get x by itself. So on the left side, we have to get rid of the plus 2, and then we have to get rid of the times 2. So it's now a question we've now done two examples of, and look, no negative coefficient. However, if you had subtracted 3x from both sides, you would have been left with, on the right side, that 1x minus 3x would have given you negative 2x. So after you move that 6 to the other side, you then would have had to divide both sides by the negative 2. You then would have had a situation where you would have had divided by negatives, so you would have to flip your inequality. So by being strategic in this case, we're actually avoiding that extra step. Alright, so let's get rid of this plus 2 by subtracting 2 on both sides. They cancel over there. So if we do that, we're going to be left with 2x is less than negative 6 minus 2. Well, that means go deeper into the negatives. That's negative 8. So you have 2x is less than negative 8. Got to get rid of the times 2, so we divide by 2. Divide both sides by 2. We're left with x is less than negative 8 divided by 2. That's a negative divided by a positive, so that's a negative. 8 divided by 2, that's 4. So x is less than negative 4. That's going to be the answer to our question for number 17. We found out that everything that is less than negative 4, not including negative 4, is a solution. Now, if you're not sure, let's test that. Let's plug in something less than that. Let's plug in negative 5. So I'll put a negative 5 right there, and let me erase some of that stuff. erasing some of the work so I can just show you what I'm doing. All right, we're going to plug in negative 5 right here too. Okay. All right, so on the left side, we have 3 times negative 5. Well, that's negative 15. So on the left side, we have negative 15 plus 2. Well, that's negative 13. So the left side would end up equaling negative 13 is what we found. Now on the right side, negative 5 minus 6. Negative 5 minus 6 means go deeper into the negative, so that's going to be negative 11. So the right side is going to equal negative 11. So we're going to be left with negative 13 is less than negative 11. Is that true? Well, negative 13 is further to the left, so yes, negative 13 is less than negative 11. So we have a true statement. So that means everything to the left of negative 4, yes, those are solutions for us. And that's an example of us checking our solution. Alright, so I'm going to do one more problem like this where it's a little bit tougher with variables on both sides. Hopefully it's making you review what you remembered from the end of Chapter 3, solving equations with variables on both sides. So now, let's look at number 19. There's a creative way to write this one. We're going to avoid using the distributive property for now, but there's a way to rewrite this question, and yes, you'll have a fraction, but it's something that's going to be within our abilities level. So I'm going to do number 19, and then we're going to call this probably one of our last questions we're going to do together. Alright, so the creative way to write this, to get rid of that denominator of 4, what we're going to do is we're going to, rather than trying to multiply everything by 4, that was one of the ways we learned how to do it, we learned that if you have a fraction, if you multiply everything by if you have an equation, or in this case an inequality, where you have a fraction, you want to get rid of that fraction, if you multiply everything on both sides by the common denominator of all your fractions, so in this case the common denominator would be 4, if we multiply everything by 4, that would get rid of our fraction. Meaning, let me briefly show you what I mean. If we multiply this by 4, this by 4, this by 4, this by 4, so everything, we would be left with A. 5 times 4 is 20. A times 4 is 4A. Negative 4 times 4 is negative 16. So this question translates to A plus 20 is less than 4A minus 16. You could rewrite number 19 this way, and now look, no fractions, none of that stuff. So some of you are going to prefer this question. If you solve the question I just wrote, that's going to have the exact same answer as if you're about to do this other creative way that I'm about to show you. Now, I think the creative way might be slightly confusing because I'm going to use the fractions, so I might come back to this way. So I'm going to write it off to the side just so we remember what it was. A plus 20 is less than 4A minus 16. Okay, so now let me erase it on my way over here. So the other creative way to write this, if you couldn't remember that, if you didn't remember that shortcut, that trick to get rid of all fractions inside of your problem, you could just do this. Rewrite A divided by 4. Instead of A divided by 4, when you divide it by a number, it's just like multiplying by the reciprocal. So instead of saying divided by 4, we could say multiply by 1/4. Multiplying by 1/4 is the same thing as dividing by 4. If you're not sure why, look at one of the previous videos we've made. So that means you can think of that as a coefficient. Negative 1, or not negative, excuse me, just 1/4 A. So 1/4 times A. Now everything else, plus 5 minus A minus 4. So now it's a question to where we just need to combine our variables still. Remember, I suggest moving the smaller one towards the bigger one. Well, the one on the right, well, that's 1A. The one on the left, that's 1/4 A. So the one on the left is smaller. So you should start by moving positive 1/4 A. If you want to avoid your negatives, you should take my advice and move the smaller one towards the bigger one. So we're going to subtract 1/4 A. Since it's positive, the opposite is minus or negative. Subtract 1/4 A from both sides. And so they cancel on the left. And so on the left side, we're remaining with just 5 is less than. Now, 1A minus 1/4 A. Well, we know it's going to be something A. So 1 minus 1/4, or 1 whole minus 1/4, or 4 over 4 minus 1/4 as common denominators. The last going to give us 3/4. So that's going to give us 3 over 4. That's what's remaining from that. Use your fraction skills if you're not quite sure where that came from. Alright, so from this step, we have one step remaining. We have to get rid of the coefficient 3 over 4, because 3 over 4, A means 3 over 4 times A, or times 3 over 4. To get rid of it, remember, the opposite of multiplying is dividing, so we're going to divide both sides by 3 over 4 to move it to the other side. This is where you're going to have to use your fraction skills to remember how to divide by a fraction. When we do this on the right side, we're going to be left with just A. So we have A, and we have that less than symbol. Now, on the left side, we have 5 divided by 3 over 4. This is where I mentioned use your fraction skills. So 5 divided by 3 over 4. 5 is 5 over 1. When you divide by a fraction, remember that means multiply by the reciprocal. So you might remember that as keep, change, flip. But we're multiplying by the reciprocal. So now we're ready to multiply. So multiply that straight across. We get 20 over 3 20 over 3 is an improper fraction. We simplify that. 3 goes into 26 times with a remainder of 2. So 6 and 2/3. So that's going to be what we're going to have over here. We're going to have 6 and 2/3. So now, so that tells us 6 and 2/3 is less than a. Remember we said it was kind of improper to have the variable on the right side. It kind of makes it hard for us to graph it when it's time to graph it. So let's just flip all of it, but make sure the alligator inequality is still eating the a. So it's going to be a, alligator is still eating the a, so a is greater than 6 and 2/3. And that's going to be your answer to number 19. Now, when you go to graph this, just make sure you use an open circle because it does not include 6 and 2/3, but it's everything bigger than that. So it'll be an open circle and it'll be shaded going to the right. Now, I mentioned earlier that a shortcut, or not a shortcut, but an alternate way to think about this question where you could have gotten rid of all those fractions was by multiplying everything by the common denominator 4. I wrote that result off to the side. A plus 20 is less than 4a plus 16. Or excuse me, minus 16. I got scrunched over there. If we go to solve that, we should get the same answer. So let's take a moment to do that. And this will be the last thing, we're going to be all done. So let's start by moving the smaller variable towards the bigger one. The smaller one is positive a, so the opposite of that is negative a, or minus a. And so they cancel out on the left. We'll be left with 20 is less than 4a minus 3a. Well, that's 3a. Or excuse me, 4a minus a. I was saying the answer. 4a minus a is 3a minus 16. So now we're just solving for a. It's just a regular two-step equation at this point. So let's get rid of the minus 16. So we add 16 to both sides. Cancel on the right side. And we're left with 36 is less than 3a. Now, at this step, our job is to finish getting a by itself is to get rid of that coefficient of times 3. So we're going to do the opposite by dividing by 3. So we're going to divide both sides by 3. And we end up with a different answer than last time. So let's see what's disagreeing. So we end up with a. And on the left side we have 12. So we have 12 is less than a. Or the opposite way of saying the same thing, a is greater than 12. So let's take a moment to see what was different. Alright, so because I was unorganized, I was cramping it. The second way on the right is correct, but the way on the left was correct until I got messy and unorganized and made a mistake. So here's the mistake. Let me backtrack. You'll notice where I subtracted 1/4 a from both sides, we have 3/4 a, but here's the mistake. Whatever happened to that minus 4 out here? I completely cut it off, and because I was scrunched with my next line, I didn't notice it. But that was the mistake here, is I just randomly ignored that minus 4. So let's go back and finish that question properly. Now, to make that easier, I am going to erase what we just did on the right side, where we end up with saying 12 is less than a, or a is greater than 12. Let's finish it on the left side, and we'll call it quits. I wanted to make sure I didn't leave you guys confused. Sorry about that mistake. But this is one of those things where not being neat and organized, look what it's leading to. Alright, so let's get this fixed. Okay, so backtracking to here, we still have that minus 4. So that means it was not time to divide by 3/4 yet. It was not time for that. So we have minus 4 going on over here. So we have to get rid of that minus 4 before we can divide by that coefficient. So the opposite of minus 4 is plus 4 on both sides. So plus 4. So they cancel on the right side. And when we do that, we're left with 9 is less than 3/4 times a. Now we can do what we talked about, where we can divide both sides by 3/4. So we're going to divide both sides by 3/4. I'm kind of running out of room, so I'm going to kind of do it sideways. So divide by 3/4. Alright, that's really messy. So 9 divided by 3/4. That's what we have on the left side. Now on the right side, they just cancel. We're left with just a. This was the mistake I made last time. I was just getting unorganized. I ran out of room. I'll make it be more neat next time, guys. Alright, so we have a still on the right side. We have the less than symbol. So now 9 divided by 3/4. Well, that's 9 over 1 times 4 over 3. Same thing as last time, multiplying by the reciprocal. Now, multiplying straight across, we end up with 9 times 4. Well, that's 36. 1 times 3, that's 3. So we have 36 over 3. Well, 36 over 3, that's 36 divided by 3. That means 12. And that should ring a bell because when we did it the alternative way in blue on the right side, we had 12. So we have 12 is less than a. So that tells us our final answer is 12 is less than a. But to make it easier for us to graph and try to make it, it's not necessarily proper, it's just easier to graph, is let's flip all of that. And let's say a on the left side, 12 on the right side, but make sure the alligator is still eating the a. So that tells us a is greater than 12. So that's our final answer. So if you hung in there for this last example, sorry for getting messy and maybe getting a little confusing, but if you listen to what I'm saying, you can hear how we should be doing it. Don't make the mistake I did. Do not forget that the -4 on the far right side, whereas I just randomly cut it off and ignored it. Don't make that mistake. Or if you like anything to help, maybe if you like the way I did it in blue on the right side, where I just simply showed how to get rid of all fractions in the question, that might be a way that gives you comfort as well to clear up this question. Regardless, guys, remember, solving inequalities, whether it be one step or two steps, or variables on both sides, is just like equations. Get your variable by itself, and that's your answer. Just instead of an equal sign, you have an inequality sign. The only difference is when you multiply or divide both sides by a negative, you got to flip the inequality sign. Study, practice, and hopefully this helps you guys out. Take care.